The objective of this lesson is to discover and use the formula area equals base times height to calculate the area of a parallelogram. In previous grade levels, students have calculated area with various figures. They have learned that the area is additive and that it can be decomposed into several pieces and still have the same value. In 6th grade, students may still confuse area and perimeter. It may help students to notice that within the word perimeter is the word rim, which means the outer edge of an object. Let's begin with the problem. Ryan is entering 2 of his paintings into an art competition. The judging categories are determined by the total area of the artwork. Help him decide which category each piece should be in. Category A, 1 to 100 square centimeters. Category B, 101 to 200 square centimeters. Category C, 201 to 300 centimeters. Or Category D, 301 or more square centimeters. The first sunrise painting is done on a rectangle canvas. The area of a rectangle is found by multiplying the length times the width. The length is 24 centimeters and the width is 12 centimeters. The area would be 24 times 12 equals 288 square centimeters. This painting would be Category C because it is larger than 201 centimeters, but it is smaller than 300 centimeters. The formula used to calculate the area of a rectangle is area equals length times width. There are alternative names for the length and width of a shape. Another way to refer to these dimensions is to use base in place of length and height instead of width. The formula can also be written as area equals base times height. Any side of a figure can be labeled as the base. The height of a figure is perpendicular measure between the point that is farthest from the base and the base itself. Sometimes this is the side of a figure and sometimes it is not. Now let's calculate the area of the sunset painting. The painting is a parallelogram. The base is 9 centimeters and the height is 8 centimeters. Let's draw the parallelogram on grid paper. The base would be 9 centimeters or 9 squares and the height would be 8 centimeters or 8 squares. Start by counting the whole squares. There are 64 whole squares. Now count each fractional piece. Each fractional square plus the fractional square opposite it along the parallel side can be added together to create one whole square. Each pair of squares can then be counted as 1. This can be added to the number of whole squares counted in the shape. 64 whole squares plus 8 made whole squares equals 72. The area of the parallelogram is 72 square centimeters. Another way to calculate the area of the parallelogram would be to rearrange it to make a rectangle. Cut the parallelogram perpendicular to any of the parallel sides and then rearrange the pieces to create a rectangle. The base or length is still 9 centimeters and the height or width is still 8 centimeters. It is known that the area of a rectangle is length times width or base times height. The area would therefore be 9 centimeters times 8 centimeters equals 72 square centimeters. Ryan's sunset painting would be in Category A because it has an area greater than 1 square centimeter but less than 100 square centimeters. Every parallelogram can be decomposed and rearranged to create a rectangle. Therefore, the area of a parallelogram is the base times the height. The objective for this lesson was to discover and use the formula area equals base times height to calculate the area of a parallelogram. We met this objective by decomposing a parallelogram and rearranging it to create a rectangle to find the area. We found that the area of a parallelogram is base times height.